tests. Okay, so the idea is numerical solution, and this popular method that we discussed is going to be Euler. Okay, we call it Euler's method. Euler's method for solving an equation, differential equation of this form: dy dx or y prime equal to the f of x comma 1. Okay, that's fine. You know that y prime from the geometrical point of view is going to be rate of change or the slope of a tangent line. So that would be the idea. Okay, I just remind you what we did with this type of idea from calculus 1. It help you. Okay, so let's review this one first. Remind you from calculus 1. It's the one we call it the linear approximation, and we did it in calculus 3 as well. Okay, linear approximation, tangent line approximation. Okay, tangent line approximation. Tangent line approximation means you can estimate the value of the function by the tangent line at the given point. We see this is the way we do it. That so a linear approximation, tangent line approximation of a function. Okay, and the function f, if you like, at x equal to the a is denoted in calculus 1. It's a tangent line. It's denoted by L of x and is defined by, that's the equation of tangent line, defined by L of x is going to be equal to the f of a. It's like y minus y1 equal to the m times x minus x1. And you solve for y. So it's going to be f of a plus f prime of a times x minus a. If you write the equation of tangent line at x equal to a, it's the same thing. And we call it L of x. The estimation is going to be, this is going to be tangent line, and you note that the value of the function can be estimated by the value of L of x, or the tangent line, if x is going to be close to x. This is the way we do it. We do it for the function of 2 variables, 3 variables. Remember, in calculus 3, in order to, okay, to get the definition of the derivative of the function. This is what we did in our derivative. So this is the graph of the function. This is going to be graph of the function. And this is going to be the point that we're going to be interested in. Okay, if it's going to be point A. So this would be the tangent line. Okay, which is your L of x. So the situation that we're going to have is that if you pick the point x, which is going to be close to the, close to the A. So if you consider it from the curve, this is going to be your f of x. If you consider it from the line, the tangent line, this is going to be what? This is going to be L of x. As you can see, there's going to be any leftover between these two is just this portion over here. So as you move x closer and closer to the A, this difference, you see the difference would be getting smaller and smaller and smaller. And eventually would be, you see that would be 0, and these two would be equal to each other. That's what you do for the function of one variable. You can estimate, you know that you can estimate 16.1 by using the function to be radical x, estimate it around 16, and then you find it. Or you can do it with the differential. We did it with the differential, or we did it with the tangent line approximation in calculus, in calculus 1 and calculus 3. Now, what are we going to do is we are going to use the same idea for this estimating the solution to the differential equation. because this is going to be your y prime, if you like. This is going to be your y prime, and we just write a formula very similar to this one for the getting the value of the function, okay, around a special point. So that was the review. Now what we're going to do is, you see this x minus a, if you get 2 points, we can call it delta x as we move on. So the situation is going to be this one. We want to approximate. So this is the problem. To approximate, I suggest the procedure. Let me do it. To approximate the solution. Okay, the solution of the initial value problem. You must have initial value, particular solution, initial value. Okay, problem means a differential equation with the given initial condition. The equation is this: y prime equal to the f of x comma y. And the initial condition is y of x0 is equal to the y. So this means the graph of the function passing through the points x0 and y0. That's the idea. So what we're going to do, we are going to estimate the solution, y. We estimate the solution around this given point, x0. It would be almost like the one that you have over here. What we are going to do, we are going to pick some point which is going to be close to the x0, and then we estimate the solution. And then we're getting closer and closer to the x0, so the solution is going to be, okay, closer and closer to the real one, if you like. So we have to repeat this formula over and over, so the repetition is going to be this one. So to approximate the solution of initial valued problem, we are going to do the problem, okay? Let's say proceed. Okay, that is going to be one. Proceed as follows. First thing to do, you have to pick your estimate. Okay, if it's going to be now estimating around 1 or around 0, you have to pick an interval. That interval mostly will be given to you. Then you divide that interval. For example, if you want to do between 0 and 1, you can divide the 10 parts, 20 parts, 30 parts. They give you the hint what they are going to be interested in, okay? So these information would be given to you. Step one, this information would be given. You have to pick how. So this is step one. Step one, you are going to choose a non-zero. Okay, and when you do the calculator, there's already a non-zero number. You have to pick the delta x if you like. Delta x, like a differential of the x or the difference of x. You know, in your book, they go with the h, so I call it h. It doesn't matter, delta x or h. This is going to be how you are going to divide those parts together, okay? They call it as an increment. You pick this one, or in your book, they call it a step size. Step size along the x-axis. Okay, you want to go from 0 to 1. How many times, you know, you're going to divide between 0 and 1? You decide that one in advance. Okay. So that would be step one. Then you are going to, when you pick those interval, then you are going to have the following numbers. You start with the x0, you see, you start with the x0. So the initial ones. The first point that you're going to pick is going to be x0 plus one of these delta x, h. Then you move to the right. You move to the right, you pick the second point. The second point, you start with the x0, you arrive at h, then you add another h to get to the next point. So it's like you already got the first one, you are going to add another h to the first one. Okay, so it's like x0 plus 2h. Then you continue. x3 is going to be x2 plus h. You have to move on, depends on the interval that you pick to get to that last interval. So It depends how many times are going to go. So in general, this is the formula. If you want to do the xn, you pick the previous number and you add the HE. I'm going to tell you that how many times are going to go. Okay, so quickly we identify these points. Between 0 and 1, you divide 10 parts. So when you divide 10 parts, and it's going to be equal parts, so the first one, x0, x1, 2, 3, 4, 5, 6, like the integration. Then you are going to use this estimate over and over, okay? So number 1, number 2. Number 2, you are going to compute the following. So compute the value of the function, y1, y2, depends, y3, up to the, let's say, yn plus 1, as follows. Exactly the formula for the estimation that we have. You see, if you want to find the y1, you already got the x0. So you find f of x0. F of x0 will be y1, y0. So you have the y0 plus, see the one that we did, f prime times x minus a, delta x. F prime in this case is going to be your, okay, your function here. So it's going to be y0 plus h times it by f of x0, y0. Remember, the initial condition is given to you. X, you got the x0, you got the y0. You can substitute into the f of x and the y to find this number. H is how we're going to divide them. So otherwise, so this is going to be the first step, if you like. Okay? Yes. Y0 plus hf, the function. F is going to be, you see in the approximation that did, look at this one. In this form, it's prime. And remember, your prime is equal to the f over here. See, your differential equation on one side is prime, the other side is the function. So we replace the function. Okay, so you start it over again. You got the y1, you go and find the y2. You get closer and closer to the actual solution. So we get the y2. y2, y1, you repeat it, plus h of f of the previous point, x1, y1. That gives you y2. Then you repeat it. y3, go back to y2, h, f of x2, y2. And you have all this information. It depends how many times you have to go. So the general formula is this one. You want to memorize that, and it's easy enough to write. So if you go with the, you want to find yn plus 1 at one step, you have to go the previous part, which is yn plus h f of x and yn. This is going to be your general formula for all of them. And that is where n is equal to the 0, 1, 2, 3, etc. So if you like the number that we got over here, y1, y2, y3, y is your function. But these are going to be the value of the solution at those points that you pick. At the point x0, x1, x2, x3. And it depends on the initial condition that will give you where to stop, okay? We just finish it. Are you done? So this is, so the numbers that we got over here, see the numbers that we have, y1, y2, etc. In this equation, it's going to be an estimate. In these equations are the approximation of, if you have the exact solution of y of x1. It's going to be an exact solution that's already given to you. If you replace x1, that gives an estimate of the y that you pick over here. Okay, and it just continue. Y of x2, y of x3, etc. So this is the way we are going to estimate it. I'm going to give an example to see how we're going to do it. And then in that example, we find the solution, and then we compare them together to see how much we're going to lose or how much we're going to gain. This is going to be the method. Okay, this method, is not bad. It's quick. It's not very precise. Okay, if you want to have a better one, then there are a modification of this, of this method here. Let's give one example to see, how easy it is to be able to use it. So let's see how you operate. This is how we're going to be given. So we give you the instruction. Use Euler method because there are other methods to use. Okay, use Euler's method. They give it a step size, be it step size of delta x, which is equal to the h, equal to the 0.1. So they fix it. So when you want to move forward, 0.1, 0.1, 0.1, 0.1, 0.1. That will tell you how we're going to divide it. Okay, use the Euler method, the step size of the delta h of 0.1 to make, okay, that's it, to make a table, approximate values of the solution. Values of the solutions. Solution of this equation of the following initial value problem. This is the problem. It cannot be getting, very complicated equation. It's going to be straightforward. Y prime equal to the y minus x with the initial condition of y of 0 equal to 3. And they ask you to do it over the interval 0 and 1. Because your initial number is 0, so you are going to estimate it around 0. They ask you to estimate it on this interval. So you have the interval which is 0, 1. The step size is 0.1, so you have to divide it into the equal parts. And then you pick those numbers that we have, you drop them into the formula over and over and over, and you're going to give us all these possibilities to be able to do. Okay, you ready? See, this is the interval is given. Look at the interval. Like the one you do for the short sum that we did for the Riemann sum. See, this is 0, 1. So we divide it into the equal parts. Each part is already given to you. The part is 0.1. So each of beats, you see it's going to must be 0.1, 0.1, 0.1. This is the way we're going to do it. So if this is going to be 0, then you move on. You see, these are going to be 0.1, 0.1, 0.1. See, 0.1, 0.1, 0.1 to get it to the 1 initially or eventually. So the points I'm going to take it from 0 to 1 are going to be how many points? Yeah. So x0, initial one is 0. Then you pick x1. You can say that it's going to be 0.1, but I write it down so that you know that x1 is equal to the x0 plus h or delta x, which is going to be 0 plus 0.1. That gives you 0.1. So x1 is going to be 0.1. And then you continue to get the other ones. Okay, so x2 would be 0.2, etc. So how many points are you going to have? So this is it. You have to find x0, 0, x1, 0.1, x2, 0.2.
Move it down.
2.3. Okay, that is going to be 0.3. And that take you to what? X9 is going to be 0.9. And eventually, X10 would be what? So we are going to estimate the solutions of the equation, okay, at all these points. And you already got the function. Okay, your function, you see f of x comma y is given to, is going to be y minus x. And the initial condition of y of 0 equal to 2. So this means what? This means x0 is equal to the 0 and y0 is equal to 2. So start estimating the first one. Okay, we already got the y0 is equal to, see, y0 is equal to 2. That's given to you. So we're going to find the y1. So y1, remember, is the previous one, y0 plus h f of x0 y0. The substitute can use your calculator to get this quickly. So y0 is 2 plus h is 0.1. The function f of what? F of x0 y0. x0 is 0, y0 is 2. And this is your function. The function is the difference between these two. So it's going to be equal to what? It's going to be 2 plus 0.1 times y minus x. 2 minus 0. Again, all of them can be done with the calculator. You don't have to write down. Okay, so what's going to be this? This is going to be 2 plus 0.2. Okay, so that gives it 2 plus 0.2. So the result would be 2.2. So y1, okay, y1 is equal to the 2.2. So this means if you have the solution of this differential equation that you call it y, and if you find the y at, okay, at 0.1, you should get 2.2. So 2.2 is going to be the estimated value of the function of the solution at, okay, at what? At 0.1. And I solve it for you, we see that it's going to be almost the same thing. Yes.
How come we said h is 0.1 and how come we broke it up into 10 parts?
Because the interval is given to you. See, the interval that I asked for estimation is 0 and 1. And you start with the 0. Okay, so the only way that you can get from 0 to 1 with that step size is just 0.1, 0.1.
How come the step size couldn't be like 0.2?
Yeah, you can pick anything you like.
Oh, okay.
But in this one, they fix it. They usually fix it.
Okay.
They usually give it true, of course. You see, this is 0.1. They ask you to do it for 0.1 and 0.01. You know, they give you through a step to compare them together. You know, when you have the software, you know, you just replace it by any number, you get it. But you have to follow the menu. But if you check the problem that you have, we mostly give you two that, you know, was summed together. So, you know that you need more points. So, okay, any question? Just do a couple of them, then I list it for you, then we go, oh, we don't have time. Then we get that, you know, you are not going to require to do it, but I just wanted to see it. I do it, then we solve this problem. It's easy to solve. It's a linear equation. We solve it so that we're able to compare them together, okay? But on the test, we just want to check it really. One case. Okay, so let's do one more, and then I list it, or you can try it to see if you get these numbers. So that's a y1. You want to do y2, same thing. You go back, y1, okay, h, f, r. You get the x1, y1. Remember, y1 is 2.2, h is 0.1, f of x1, y1. Your x1 is 0.1. You see 0.1 and the 2.2. go to the function, you substitute. So this is going to be 2.2 plus 0.1. The function was y minus x. So it's going to be 2.2 minus 0.1. Okay. So that's going to be 2.2. You subtract this one, that give you 2.1. Okay, that give you it's going to be 0.1 times 2.1. So that's going to be 2.2. And this is going to be what? It's going to be 0.21. 0.21, if you add them together, so your y2 is going to be, y2 would be 241. See, that's going to be y2. On the test, you can write, a couple of them for us. Then the rest, you just give us the result from your calculator. So I give you those results, okay? When I post it, you have more numbers, but this is what you get for the others. So you get the y3. If you do it, the y3 would be 2.631. And if you go with the y9, you do 4.5795. Eventually, y10 going to be 4.59377. Okay. Next time I solve that equation so that you can compare them together to see really they are close. Okay. Okay, so that's the only thing we do for this numerical. That will take us to chapter 3. In chapter 3, we have different modeling. I'm going to pick two models for you. I work on it, and you get the idea. We give you a similar one on the test, but we make up something. Like one of them, like the one. Okay.
When's our first test?
Like a week from
2 weeks.
The test,
Yeah.
the test is going to be 2 weeks from now. So next week we finish those modeling, and then we have a test.
So the next thing we
So
have.
your test would be up to
Weeks
the
from
two section from chapter 3.
a week from next Tuesday.
You take it up to this equation of the second order.
Everything was so good. See you. Have a good one.